Hey folks, we're back for week 3 of coronavirus quarantine lockdown. So we are still teaching remotely. This week, one of our topics is going to be called completing the square. All right, so this is another method for solving quadratics. We've already gone through graphing as a way to solve. We've gone through the square root method as a way to solve. So this is the third method that you're going to use in order to solve quadratics, and there's only one more method after this one, okay? So this one is called completing the square, and it kind of picks up where we left off last week with the square root method, okay? When you have a quadratic that's in standard form and it's a perfect square trinomial, it's incredibly easy to solve. Okay, so I'm actually going to start by showing you one of the examples that you did last week in order to kind of pick up where we're going to start this week. So this was number 14 that you did last week. It looked something like this. It says x squared minus 4x plus 4 is equal to 0. Notice that our quadratic is always set equal to 0, okay? Right here, we're going to just factor this quadratic, right? So you took your two binomials, you wrote them out like this. You've got x and x. You needed factors of 4 that add up to -4, okay? So factors of 4, well, that would be 2 and 2 would work, but I need them both to be negative because my middle term, my b here, needs to be a -4. So I've got x minus 2 and x minus 2, and this whole thing is equal to 0, okay? So I factored it into the two binomials. They're the same binomial, so we can write it as it's a perfect square trinomial. So we can write it as x minus 2 squared is equal to 0. From here, you took the square root of both sides. That gave us, what was that? X minus 2 is equal to plus or minus the square root of 0, which is 0. And then we're going to add 2 to both sides, and that gave us x is equal to 2. So in this quadratic, it actually only touches the x-axis one time, okay? And so when we start with the square, with completing the square, we're going to see how we can use this to give us some more information about the quadratic just by looking at the function itself. Okay, so I'm going to take you through some steps on how to solve. So I am on page 471. All right, this is lesson down here, lesson 32-2, and I'm on page 471, and I'm going to take you through example A. All right, it gives you all the steps listed out here, which I think is wonderful, and I'm going to work them out with you too, just so you can have just kind of like someone instructing you here on how to do this. Okay. All right, so it tells us to solve, this is example A. It tells us to solve the quadratic x squared plus 10x minus 6 equals 0. It tells us to solve it by completing the square, okay? So if I just look at my quadratic, I've got it set equal to 0 right here, but this one is not a perfect square trinomial, okay? It's not a perfect square trinomial. In fact, like if I took 10 and I divided it by 2, 10 divided by 2 is what, 5? And then squared that term, I would get 25. Well, my C term right here is not 25. So factors of -6 that add up to 10, that's not going to be a perfect square trinomial, okay? So what we're actually going to do is we're going to force this quadratic to be a perfect square trinomial, all right? So step number 1, and this is, you can follow along on your page, is to isolate the variable terms. So you've got this quadratic is in standard form. The first two terms have variables in them, right? They both have x's. Well, our last term, C, does not. So we're going to take C and we're going to move it to the other side of the equal sign, okay? So that's going to give us x squared plus 10x is equal to 6, right? Because I add 6 to both sides, okay? So we added 6 to both sides. That was step number 1, okay? Step number 2 is the actual step where we're going to do what's called complete the square. Okay, so we are going to complete the square. Okay, Now, I like to do these little boxes kind of like they have on the example here. So we have x squared plus 10x plus, and I'm going to put a blank, equals 6 plus, and I'm going to put a blank, okay? So let's force this side of the quadratic to be a perfect square trinomial. So here's how we do it. It's a small little equation. It says something like b divided by 2, and we're going to square it. B divided by 2 squared. That's how we're going to force this quadratic to be a perfect square trinomial. Well, in this case, b, which is the coefficient of our middle term, is 10. So I'm going to put a 10 in place of b. I'm going to divide it by 2, and then I'm going to square that number. So 10 divided by 2 is 5, and 5 squared is 25, okay? So I am going to put 25 in this blank right over here. And guess what? What I do to one side, I'm also going to do to the other side of my quadratic. So I'm also going to add 25 over here on the right-hand side. Okay? Now, if we just look at the left-hand side, we have a perfect square trinomial. Woo! That's what we want. That's factorable. Okay, so let's factor that into our two binomials. I need factors of 25 that add up to 10. Factors of 25 that add up to 10. Well, 5 and 5, right? So I could factor this into x plus 5 times x plus 5. So I just factored the left-hand side, equals, and then I'm going to add together on the right side 6 plus 25, which is 31. Okay? Now, since this is a perfect square trinomial, we've got these two binomials here that are the same. We can write them as a binomial squared, right? X plus 5 squared is equal to 31. Now, this step should look familiar, right? Right here at this point, it looks like what we did last week when we were using the square root method. Okay, so from here, you're just following the method steps from last week. So if I want to solve for x, first thing I need to do is get rid of that square, right? The opposite of squaring a number is taking the square root. So I'm going to take the square root of both sides, right? Don't forget your plus and minus right there in front of your square root of 31. Okay, so that's going to give us x plus 5 is equal to plus or minus the square root of 31. Now 31 is not a perfect square, so we're just going to leave it underneath the radical. If we could simplify it, we would, just like we did weeks and weeks ago when we simplified radicals. But this one cannot be simplified, so we're just going to leave it the way it is. We are going to move this positive 5 over to the other side of the equal sign. So we're going to subtract it on both sides, minus 5 on both sides. And that would give us x is equal to negative 5 plus or minus the square root of 31. Okay? So if I asked you how many solutions does this quadratic have, or how many roots does it have, you would have how many? 2. You have 2 of them. In fact, we can even split it into those 2 answers. The first one would be negative 5 plus the square root of 31, and negative 5 minus the square root of 31. And those are your 2 answers. Those are your 2 solutions. That's where this quadratic would hit the x-axis, okay? All right, I encourage you to try this problem over again. Look at the steps again and just kind of refresh your mind on what we did. Go to the next video where I'm going to try these A. I'm actually going to do problem B first, and then I'm going to have you try A on your own, okay?